we're given the equation of a plane and we're given the equation of a line. Notice we're dealing here with vectors. And from the information that we're given, we can make a little drawing that will help us make sense of the situation. So there is a plane, and we're given the plane in the form of an equation of a plane using the normal vector, meaning that we visualize it like this. So this is the plane and this is the normal vector. And then we're given a line, and the line seems to be perpendicular to the plane, meaning that the line goes sort of like this, or wherever else it goes. That means that the line is parallel to the normal vector of the plane which we're given in here. Hence, to solve part A, finding the value of k, we just need the direction vector of the line and the normal vector of the plane. And since they're going to be parallel, we can write them down. This one is going to be 4 minus 2 and minus 1. And this we know from the rule of the line, because you can rewrite the line as r times 4 minus 2 minus 1 is equal to 1, and hence this is the direction vector. So this one is going to be equal to the direction vector of this line times some parameter, and we're going to call the parameter, let's say a. And this one is minus 2 plus 1 we get from here, and k. And clearly you can see that essentially what we're doing is we're multiplying this by minus 2. So minus 2 times minus 2 is 4. 1 times minus 2 is minus 2. And so k times minus 2 is equal to minus 1. And of course we from there find that k is equal to a half. Next thing we're asked to do is to find the coordinates of the point of intersection of the line and the plane. And this we're going to do again using these two equations. And what we need to do first is simply take what we're given in terms of k and sub k inside to see what the line actually looks like. And when we do that, we get that x is equal to 3 minus 2 lambda. That of course hasn't changed. From this we get y is equal to 0 plus lambda, and z is equal to minus 1 plus a half lambda. This is our line. You can rewrite this as r is equal to, and then vector 3, 0, and minus 1, plus lambda times 2, 1 and a half. You can rewrite it in any form you want to. But this form is convenient for us because all we need to do is we need to sub each of these equations into the equation that we were given at the top. And so doing that, we get 4 times, I hope you can see this, 4 times, I'm trying to make you see both this and this. I'm going to push the problem upwards in just a second. 4 times x, which is 3 minus 2 lambda, and then we have minus 2 times y, which is lambda, and for z we write minus 1 plus a half lambda, which we get from here, is equal to 1. We don't need this equation anymore. We're now just working with what we have at the bottom here. And all we have to do now is find lambda, which is a parameter. And then using that parameter, we're going to find the point. And how do we find the parameter? This is quite simple. So 12 minus 8 lambda minus 2 lambda plus 1 minus a half lambda. Again, you don't have to use lambda. I was taught to use lambda, that's why I use it. That's the only reason. And when we clean this up a little bit, we get that 12, because the ones cancel, 12 is equal to 10.5 lambda, or you can rewrite that as 21 over 2 lambda. Hence, lambda is equal to, if you go 12 divided by 10.5 or 12 divided by 21 over 2, you get 12 times 2 divided by 21, which is of course 24 over 21. And now we know what parameter this line that we have drawn up here has. And so all we need to do is take the original equation of the line and put the parameter that we have just found inside to find the points x, y, and z that satisfy this. And that is, again, not a difficult thing to do. I'll just put it here. X is then equal to 3 minus, and then 2 times 24 over 21 gives us 48 over 21. And then for y, we get that y is simply equal to lambda. So y is equal to 24 over 21. And for z, we get minus z is equal to minus 1 plus a half lambda, which is a half lambda is 12 over 21. And so now I can push this up. From this, we get that x is in fact equal to 5 over 7. Then we get that y is equal to 8 over 7. We could have simplified lambda. If you divide by 3 the numerator and the denominator, you get 8 over 7. And z is equal to minus 3 over 7. And this here is our answer.